Hello everyone. Today I'm going to talk about the explanation of internal fan in Fluent, since I think Fluent has not done a good job explaining it in its tutorial, so I've decided to make this video. So basically the problem is we have this fluid volume and we want to create a internal fan inside the fluid volume, and the application is, for example, you have a electronic cooling project and there are some internal fans inside. So what to do about it? So the way to go about it is to create basically a plane inside the fluid domain wherever you want, and just create a surface. And to do it, let's just create a plane somewhere in the middle of this domain. So to do that, you just select these two faces, and then when you click plane, automatically it's going to create a plane in the middle of this domain. And then you just select this plane, and then plane view, and then you go and create just a circle to represent the fan. I put 5, and then we just exit, and a surface is created here. It's inside there, so we don't see it, but it has been created. So the next step is to push these two objects, including the fluid domain and the fan, into one body. So basically, you go here and you create, and then move to new component, and let's just call it component 1. And the next things to do is you have to use shared topology, so you can so the mesher can recognize it. So click share topology, and you can see this this circle has been shared, and you just click that. And to make sure that it has been shared, if you click that, the share topology has this merge sign, which basically says, we've done this correctly. So we are done with that, and we exit the space claim, and then we go to mesher. So we open the mesh in Ansys, and in order to see if we have the fan inside this domain, let's just make a cross section and see what's going on. And as you can see, you can see this fan. So what we done with shared topology has been working correctly. So the next step would be just to mesh it, and then just do some name selection. But before meshing, let's just do a name selection. So what we do, we go to surface, and then we select this surface and create a name selection, and just conveniently we call it fan. So we have a fan here, and then we have a fluid domain. So basically we go there and create a name selection, fluid, and then we just mesh it, and it's ready to go to Fluent. It has been meshed by we think that we have done this setup correctly. So let's go to Fluent and let's see what we can do there. So we've opened the Fluent, and just to make sure the fan boundary condition has been implemented correctly, let's go to cell zone conditions, and we've got one fluid, which is correct, and then when we go to boundary condition, automatically it assigns a fan boundary condition to the surface that we name selected as a fan. So when we click, the first thing that we need to know, it's basically it's a pressure profile or a specification of fan, which basically tells you what is the pressure drop based on the flow rate. But before that, it gives you a direction for the direction of the flow. So if it is not in the direction that you desire, just go here and change it. But you may wonder why instead of pressure, why it doesn't take the velocity. The reason is because, as you know, fans do not work in a constant flow velocity. The velocity of flow changes based on the downstream pressure drop. So let's just go to internet and see what we can learn. Basically, the Fluent needs to know what is the intersection between the fan specification and the system, the system pressure curve. So Fluent needs to know this fan specification curve, and then it does some trial and error to find this point, because it can calculate the pressure drop downstream. And when it gets to this point, then it knows which velocity it needs to select. So you have to know the curve of your fan. And one way is to just go to the manufacturer data that when you buy, you have it. So for example, I got this fan and it doesn't give you the curve, but even if you have 2 points, you can make that curve. For example, it gives you maximum airflow and the static pressure is 0, and it gives you maximum air pressure when the flow rate is 0. So with these 2 points, simply you can go here and then select piecewise linear, and then it asks you how many points do you have. Just say 2, for example, and just enter the velocity and the pressure drop, and then you are good to go. So the Fluent is going to calculate the downstream pressure drop, and based on that is going to assign a velocity. So that was something that I couldn't find it in Fluent that it explained well. So I decided to make this video. I'm not going to run this simulation. I think the rest should be easy. Just one thing to note for this case, because we just have a simple fluid volume, it seems that Fluent doesn't like to get the inlet velocity for the boundary condition. So you have to provide the inlet and outlet pressure as a boundary condition. So that's something to note. But other than this, if you have a complicated fluid volume, you are free to use any inlet and outlet flow boundary condition. I hope you guys like it. Please subscribe to my channel so you can see more of these videos.